Okay, so we have this question here. It is asking us which of these options is vector quantity. Now, for those of us who have learned the list by heart, they know it's weight for sure. But let's say if you forgot the list and if you haven't learned the list, how would I know that which of these options is correct? So it's very simple. Vector quantities and scalar quantities have one thing similar, which is the value, right? It has some sort of value. But vector quantities have one thing that is different from scalar quantities, which is it has direction. Okay, so let's check which of these options is linked with directions. So let's talk about efficiency. Now, for example, you have a machine, right? It's doing something, okay, and you provide him like 110 volts, you provide him this much of power, right? So you should know by now that 100% of this 100 watts is not going to be used. It's going to be wasted in some sort of sound, maybe some heat and power. Like it's being distributed, right? It's not been 100%. 100% of 100 volt is not being used. Okay, so we use efficiency's formula to calculate how much of the power I provide is being used for this machine to operate well. Okay, that's it. It doesn't have any relation with the direction at all. Even if you move the machine a little bit to the left or to the right, the efficiency won't change. The efficiency will remain the same. So let's talk about the next part, which is kinetic energy. What is kinetic energy? So you have this ball and it has some mass. Now this ball start moving at some speed. That is kinetic energy, simple as that, right? So it doesn't matter which direction you go, whether you go forward, backwards, left, right, or any diagonal directions, it doesn't matter, right? So kinetic energy has no link with direction. So let's go to the next option. It says power. Now what is power? Like for example, I have 100 joules, like I'm providing some machine 100 joules for 20 seconds, right? So power is how much you are providing, how much energy you are providing per second, right? Per second, for 1 second, how much energy I'm providing. That's it. It doesn't matter. It doesn't have any link to directions. Okay, so let's talk about weight. Like other options are incorrect, so of course weight will be correct, but how would I know that weight is correct? That's the question. So for weight changes depending on where you are. Like for example, Earth, Mars, Moon, right? But like they have one thing in common, right? Their gravity pulls you downwards, right? And that's the main thing. Like gravity is pulling you downwards. So this pulling you downwards has a direction, right? So we can say that weight has a link with direction. So even if you calculate weight is mg, right? Your mass and the gravity, right? The gravity value. So from this value you get how much you are being like pulled down. That's it. That's how I know that option D is correct.